start Unit 1, the Atom, Chapter 1, Structure of the Atom, Part 1. At the end of this video, you will be able to identify the fundamental particles of the atom, define atomic number and mass number, write the atomic symbol and the shorthand notation of an atom. So what is an atom? An atom is the smallest unit of matter that forms a chemical element. Every solid, liquid, gas, and plasma is composed of a neutral or ionized atoms. In this chapter, we are going to talk about the neutral atoms. Now, what is the main structure of the atom? Every atom is made up of two parts: the nucleus, which is located at the center of the atom, and we have the electron cloud, which moves around the nucleus. Inside the nucleus we have what we call protons and the neutrons, while inside the electron cloud we have the electrons. Protons, neutrons, and electrons are called subatomic particles. Protons are positively charged, electrons are negatively charged, while neutrons are neutral. The nucleus itself contains particles called the nucleons, which are the total number of protons and neutrons. Now moving to table 1.1, which shows the list of fundamental particles and their characteristics. This table is found in your book, page 21. Now for the first type of subatomic particles, which is protons, the symbol for protons is P+, written as an upper subscript. Now the relative charge of a proton is 1+. The mass in kilogram for one proton is equal to 1.67 times 10 to the power minus 27. The location of protons inside the nucleus. Now what about the neutrons? The symbol for neutrons is N0, written as an upper subscript. Relative charge is 0 since they are neutral. They are non-charged particles. For the mass in kilogram, it's equal to the mass of a proton. It's equal to 1.67 times 10 to the power minus 27 kilogram, and the location also inside the nucleus. Now going to the electrons, the symbol for electrons is E-. The relative charge is 1-, and the mass in kilogram is equal to 9.11 times 10 to the power minus 31 kilogram, and the location, it's outside the nucleus. They are located in the electron cloud. So the mass of a proton, of one proton, is almost equal to the mass of a neutron. An electron has a mass which is equal to 1/1836 that of a proton or a neutron. The electric charge of an electron is negative, denoted by -E or 1-. A proton is assigned the standard unit, positive charge, +E or 1+, and for the neutrons, a neutron is a neutral, that it has no charge. Now, what do we mean by the atomic number? The number of protons in the nucleus of an atom is known as atomic number, and it is represented by the symbol capital letter Z. So Z, it's equal to the number of protons. Now, what do we mean by mass number? the mass number, it is equal to the total number of protons and the neutrons, or the total number of the nucleons that are present in the atomic nucleus. The symbol for the mass number is capital letter A. So we can say that the mass number, capital letter A, it's equal to the number of protons plus the number of neutrons, or we can use their symbols and you can say it's equal to Z plus N. Let's solve these applications to understand more how to calculate the atomic number, mass number, or the number of neutrons. We will start with application number 1. The number of protons in magnesium atom is equal to 12. Determine the atomic number of magnesium. Since the atomic number, which is denoted by the capital letter Z, it's equal to the number of protons, so we can say that Z equal 12. So the atomic number of magnesium is equal to 12. Now we will move to application number 2. Sodium atom contains 11 protons and 12 neutrons. Determine the mass number of sodium atom. So I'm gonna use the relation between mass number, atomic number, and the number of neutrons. So here in this relation, capital letter A is the mass number, capital letter Z, it's the atomic number, capital letter N, it's the number of neutrons. Here you need to calculate capital letter A, which represents the mass number. But first, you need to prove what is the atomic number. So we will say here atomic number equal capital letter Z, it's equal to the number of protons, and they are given. So Z equal 11. Now just substitute the two values. We will get that A equal 11 plus 12 equal to 23. So the mass number of sodium atom is equal to 23. Now, the composition of the nucleus of an atom is shown by its atomic symbol. We use the chemical symbol with two additional numbers written to its left. The generalized form is the following. We have X, A, Z written in the following way. Here X is the chemical symbol for the element, capital letter A it's the mass number, and capital letter Z it's the atomic number. Although all atoms are composed of electrons, protons, and neutrons, yet the atoms of one element are different from those of another element because they have different number of protons in their nuclei. The number Z, or the atomic number, determines the identity of each kind of element. The following table 1.2 shows the atoms of the first 10 elements and showing their symbols, atomic number, the composition of the nucleus, mass number, and the number of electrons. This table is found page 22. Now, if I asked you to write the atomic symbol for hydrogen, for carbon, for nitrogen, and for oxygen, so you have to write the following. The atomic symbol, it's XAZ, where X is the chemical symbol of the element, capital letter A, it's the mass number, capital letter Z, it's the atomic number. Now, looking at the hydrogen atom here, you have the chemical symbol. So here X is capital letter H. You have the atomic number, so Z equal to 1. And you have the mass number, so here A equal to 1. So we can say that the atomic symbol of hydrogen is the following. Now what about carbon? You have the chemical symbol, capital letter C, you have the atomic number, it's equal to 6, and you have the mass number, which is equal to 12. So we can say that the atomic symbol of carbon is the following. So we just substitute the chemical symbol in the middle. Here we have the mass number, capital letter A, which is equal to 12, and below we have the atomic number, which is equal to 6. The same for nitrogen. Atomic number is equal to 7, mass number is equal to 14. So the following is the atomic symbol of nitrogen. And finally, for oxygen, we have atomic number equal to 8, the mass number is equal to 16. So you have to just substitute them in the general form. So the atomic symbol of oxygen is the following. The atomic symbol is also called the nuclear symbol. Now for the shorthand notation of an atom, it is written as X-A, where X is the chemical symbol of the element, capital letter A is the mass number. For example, C-12 is read carbon of mass number 12. This remark is found page 22. Now moving to application number 5, write the shorthand notation of boron. So here boron have the chemical symbol, capital letter B, atomic number equal to 5, and the mass number is equal to 11. So the shorthand notation, it's equal to X-A, where X is the chemical symbol, A is the mass number. So here we can say directly that the shorthand notation of boron is B-11. Thanks for watching. See you next time.